Hi guys, good night everybody. Just let me know if you guys can hear me before we start, please. Alright guys, sorry about the late start, right? Sorry about the late start. So let's start quickly, right? So this is my third sample exam for you guys here, right? I hope that you all got a chance to go through the first two exams, right? Basically, it would have covered a lot of the material that you may see on that exam tomorrow, right? So let's start with this first question here. We want to work out using a calculator or otherwise. So you see, whenever you guys see this in the exam, using a calculator or otherwise, forget this piece here, right? Just go ahead and use this, right? In the paper too, you are allowed to use this, so go ahead and do that, right? Let me pull up this calculator here for you all. Right? So what we're trying to work out, right? We're trying to work out 12 over 25 multiplied by 5/8 in brackets, and then you're going to divide that by 2/3, right? Now, at this level here, guys, you should be able to use your calculator effectively, right? So if I want to work this out here, I'm going to use the brackets in my calculator, and I'm going to type it exactly as I see it here. So it's going to be 12 over 25, right? And you're multiplying that by 5 over 8, close brackets. So you're going to close the brackets here, and then we're going to divide this by 2/3, right? And we're going to get 9 over 20, right? And what CSEC is concerned about here is just the answer, right? So we're just going to put 9 over 20 as our answer in this case here, right? So for this one, right, 9 over 20. So don't spend 10 minutes trying to work out these fractions here, right? Use the calculator, right? You can do it. The second part here, we want to work out 25 divided by 0.2 to the power 4. Again, we can use the calculator for this one as well. So we can see that 25 divided by 0.2 to the power 4. So you're going to press 0.2, y to the power x, and you're going to press 4, and you're going to get this answer here. So that's 15,625. Right? So we've used the calculator to work out both of these here, right? Let's move on to the next part here now. Now, a lot of schools and a lot of teachers, they kind of leave out this topic for the most part, right? So this topic here is what we call bases, right? So we have a number here, right, that is expressed in base 2, and you want to write this number in base 10. So a few years ago, I think it was in 2019, CSEC brought a question like this, and a lot of students, they had no idea how to work out that question, right? But this one here, we have 1, 1, 0, 1, 1, and we're dealing in base 2 here, and you want to write that in base 10, right? So here's how you do this if you want to write this in base 10. The first thing I would do is to put small numbers on top here. I'm going to start with 0, 1, 2, 3, and 4, right? Now here's why that is important. What we're going to do, we're going to take this number here, right? This is base 2 or in binary, and we're going to express that in base 10. So here's what you're going to do. The first thing I'm going to do, I'm going to say 1 multiplied by, now it's base 2, so you're going to put 2 here, and I'm going to use this number that I just wrote on top here. So that's 2 to the power 0, right? Plus, we're going to take the second digit here, right? This 1. So it's going to be 1 multiplied by 2 to the power, this number here, 2 to the power 1. I know some of you all watching this and thinking, I don't remember this at all. Plus, right, we're going to take this 0 here. So it's going to be 0 multiplied by base 2. And the number we're going to raise it to here is 2. Close the brackets. Plus, we're going to take this 1 here, and we're going to multiply that by, we're in base 2, and the number we're going to raise it to is this 3 here, right? Close brackets, plus, and then the last bracket now is going to be 1 multiplied by, right, 2, and it's 2 to this power here, right? So now, the mistake that some students make with some of these questions here is that this 2 to the power 0 here, they forget that that is actually equal to 1. So 2 to the power 0 is 1. 1 multiplied by 1, you're going to get 1, plus 2 to the power 1 is 2. 2 by 1 is 2, plus 0 by 2 squared is going to give us 0, plus 2 cubed is 8. 8 by 1 is 8, plus we have 2 to the power 4. That's 2 by 2. That's 4 2s are 8. 2 2s are 4, 2s are 8, 2s are 16. So this is going to be 16 here, right? So therefore, when I add this up here, 8 and 2 is 10, so that's 26. So this is 27 here in base 10. Like I said, this might be looking a little strange, but I've seen some of you all putting 27 as the answer. Yeah, 27 is the correct answer, right? Somebody saying they remove this from the syllabus. No, that's not true, right? That is not true, right? I don't know where you are getting that from, but that is on the syllabus, by the way, right? Number systems are on the syllabus. So you guys have to be able to convert from base 10 to any base that they access, and you have to be able to convert from any base to base 10. That's on the syllabus, right? So let's move on to the next one here. You all could always go back to the video if you need to. So this one here is on consumer arithmetic. Andrew purchases a car. He makes a deposit of $20,000 and pays a monthly installment of $3,500 for 4 years. Calculate the total sum paid for the car, right? Now with these kinds of questions here, right, we need to read the question and try to understand what is this, what they are asking us here, right? That's what we need to do. So in this case here, we make a deposit of 20,000 and then you're making these monthly installments of 3,500, right? So what's the total sum paid for the car? So it's going to be 20,000, right? That's the down payment, plus, now the thing is you're making installments every month for 4 years. In 1 year, you have 12 months. So if you have 4 years, it's going to be 12 by 4, which is 48. So therefore, he's making a total of 48 installments, right? And each of those installments is 3,500, right? So if you want to work out the total value that he's paying for this car here, right? So that's going to be 48 multiplied by 3,500, right? Plus 20,000. And you're going to get 188,000, right? So one, right? So this is typically, these are real life examples here, right? If somebody wants to purchase a new car, they have to make a down payment and then they're making a monthly installment. And typically it might take 4 to 5 years or sometimes more to actually pay out for the car, right? So that's part one here. That's the value for this car here, 188,000, right? The next thing here now, the insurance paid on the car in the first year was 20% the value of the car. Calculate the amount paid in insurance in the first year, right? So they're telling us how you are paying the insurance. Now remember, when you purchase a vehicle, right, you're going to have to take out insurance on the vehicle, right? And in this case here, we're just finding 20% of that value. So if you want to work out the insurance, it's simply going to be 20% multiplied by the 188,000, right? So that's going to be 188,000 multiplied by 0.2, and the insurance here, right, is going to be 37,600, right? That's a very big insurance, by the way, right? What they normally do with insurance is that they give you discounts, right? If you've never gotten into an accident, so they give you a whole set of discounts. So the actual figure is going to be way much less than this, right? Now, the third part here, they said the car depreciates at a rate of 12% per annum, right? The insurance company charges 20% the value of the car, as before. Calculate the sum paid in insurance in the second year of owning the car, right? So here's what you have to do for this particular question. For the second year, we need to actually find the value of the car in the second year, right? Let me see if I can copy this question across here so we don't, yes, so. All right, let's try to understand this question. So the first thing we need to do, we need to find what is the value of the car after 2 years, right? Now remember yesterday we did a question where we had appreciation, where the value of land was increasing, right? And the formula that we use this. The amount is the principal multiplied by 1 plus the rate over 100 to the power n or the power t, right? This is the formula that you use to work out compound interest. But you can actually use that same formula in order to calculate your depreciation as well. We make a slight adjustment to the formula and we just put, right? Yeah, we make a slight adjustment and what we do, we put a minus sign here. So what I'm going to do, I'm going to work out the value of the car after 2 years. So we're going to start off, the value of the car initially was 188,000. Right? And we have 1 minus, so the depreciation is 12%, so that's 12 over 100. And you want to work it out for 2 years, so you're going to put 2 inside it, right? So this is actually 188,000, right? Now 1 minus 12 over 100 is 1 minus 0.12, so that's 0.88 squared. So this is going to be right. So this is the actual value of the car after 2 years. It's 145, right? $587.20, right? So that's the value of the car after 2 years, right? I hope that making sense. I see some of you all kind of have that there. Right? So that's the value of the car after 2 years, right? So the question wants to know what is sum paid in insurance. Now, if the insurance is 20% of the value of the car, all we need to do is to work out 20%, right? Multiply by that figure we just got there, right? Which is 145, right? 587.20, right? So this is your insurance here, right? Which is 29,117.44, right? That's insurance. Am I making sense? I've seen some of you all have that as an answer, right? Now the key with some of these questions is to try to read and try to understand what is being said, right? There's not going to be a fixed way they're going to ask the question. You have to read the question, try to understand what is being said, right? All right, so that's third part. And the final part here now. No, hold on, just now. I'm missing a piece here. Right. Now, the car is sold after 6 years and it's sold for $90,000. What is the percentage loss? Right? You guys need to be able to calculate percentage loss. So, percentage loss, right, is simply going to be whatever the loss is. So in this case, you purchase a car for $188,000, right? Now you're selling it for $90,000. So therefore the actual loss is, you need to subtract these two numbers. That's your actual loss. And you're going to divide that. Now the most common mistake that students make here when they're trying to work out percentage loss is that they don't know what to divide it by. You're always going to divide it by the original value, right? In this case, the original value is 188,000. And we just need to multiply this by 100, and this will give us our percentage loss. So it's going to be 188,123 minus 90,000 divided by 188,123, and you're going to get 52.1%. Right? So that's the percentage loss here. You guys need to be able to calculate percentage loss as well as percentage gain, right? All right, I've seen some of you all have that answer. Great. So that's the percentage loss. We just have one more part to complete this question. A sum of money, right, is shared between Kyra and Paul, right, in the ratio 3-5. Kyra received $90. What is the original amount of money that was shared, right? So let's put K, right, and P, and the ratio is 3-5, right? So that means that we have a total of 8 equal parts, right? So the whole is actually 8 equal parts here. But the thing is, you know what is Kyra's share? Her share is $90. So this here is $90, right? Now the thing is, if her share is $90, we can figure out what is one share, right? One share, right, is simply going to be $90, right, divided by 3. So one share is going to be $30, right? That's one share. Now if you want to figure out the total amount of money that was shared, the total amount of money is actually 8 parts. So therefore your total at the beginning, right, or the total, right, is simply going to be 8 parts, right, multiplied by $30, right? So this is going to give us $240, right? So this is a simple ratio question, right? Right, so that takes care of question 1, right? We have a good few questions to work, so let's move a little faster here, right? We have 2 factorizing questions to do here, right? The first one, right, we have 16 minus 4x squared. So that is actually the difference of 2 squares. So what I normally tell my class to do, first write it as the difference of 2 squares. So 16 minus 4x squared, we can write that as 4 squared minus 2x squared, right? Once you write it like this, then when we factorize it, it's very easy to see what we're going to put in a bracket. So in this case, it is going to be 4, right, plus 2x, right? And we can say 4 minus 2x, right? So this is what we get when we factorize this here, right? Now sometimes they may ask us to factorize fully, right, which is something we could do, right? Because in a question like this here, if they had said fully, right, watch what we could have done. We can see, we can pull out 4, right, open brackets, 4 minus x squared, right, and then we can write this as 4 open brackets, right, 2 plus x in one bracket, and then 2 minus x in a next bracket, right? So if they ask us to factorize fully, we're going to give them this as the answer, right? So look out for these words in the exam question. I didn't put fully here, but if they had said fully, then this is going to be the answer, right? So keep that in mind. For the second one here, this one here is a quadratic, but some students for some reason have a little trouble factorizing this. So in this case here, we have 2x squared minus 6x. So the HCF of 2 and 6 is 2. The HCF of x squared and x is simply going to be x, open brackets. If you want to get back the 2x squared, we need to put an x here, and then we're going to put minus 3 here, right? So this is my answer when I factorize this, right? All right, so I've seen some of you all right? Yeah, guys, I see somebody saying something there. Yeah, we have more than 600 and something students here. Guys, please remember to hit like and please subscribe, right? I am doing this out of the goodness of my heart, right? I love to teach, so please do so for me, please, right? All right, the next one here, we have an inequality that we're trying to solve, right? We have minus 8, sorry, right? And then we have 3x minus 2. And we have less than or equal to 7, right? Now, whenever you have an inequality where we have more than one inequality sign, the objective is to end up with x alone in the middle. That's the objective, right? To end up with x alone in the middle. So what I would do in a question like this, right? The first thing I need to do is to get rid of this minus 2 here, right? So that minus 2, in order to get rid of the minus 2, we need to add 2 to every section inside this. So this is going to be minus 8 plus 2. Right? Leave that sign here. This here is going to be 3x. This here is going to be 7 plus 2. Right? Now, minus 8 plus 2 is going to give us minus 6. Right? We have 3x here. We have less than or equal to 9. And then, remember the objective is to to ensure we have an x in the middle only. So you see this 3 here? We need to get rid of that. So divide every single thing by 3. So therefore, minus 6 divided by 3, you're going to get minus 2. Right? You're going to end up with x here, and then you're going to end up with 3 here. Right? So therefore, so this is our solution here. Right? This here is our solution. Right? So that's the answer for part 1. For part 2 now, they want all the integer values, right? All the integer values between minus 2 and 3, right? So the integer values in this case here, if we look at the inequality, it has to be greater than minus 2. So minus 1, 0, 1, 2, and 3, right? We need to include the 3 because of this inequality sign here, right? So we're going from minus 1 right up to positive 3. Right? All right, so that's 2 part B. This next one here, we want to make r the subject of the formula, right? So we have r is equal to the square root of 2k minus 7, right? So r is equal to the square root of 2k minus 7. Now, anytime you see inequalities where we have a square root sign and we want to get rid of it, what we need to do is to square both sides. In this case here, if I square the left side, I'm going to get r squared. On the right side, you're going to get 2k minus 7, right? Now, the objective is to make k the subject of the formula. So what I can do, I can write this as 2k minus 7 is equal to r squared, right? And therefore 2k is equal to r squared plus 7. And therefore k is equal to r squared plus 7 all over 2, right? So that's my answer for that one there. We're making k the subject of the formula, right? Now, part D, the cost of 4 pens and 3 pencils is $18. The cost of 2 pens and 9 pencils is $24. Write a pair of simultaneous equations to represent the information using x to represent pens and y to represent pencils. Now here's a piece of advice here. Whenever they give you information like this, take a pencil and write down exactly what is x and what is y. So in this case here, x represents pens, so therefore put an x here, right? And y is pencils, so you're going to put a y here, right? Put an x here and put a y here. So if I want 2 equations, right? They said 4 pens, so let's put 4x plus 3y, right? And the cost of that is $18, right? And the second equation, we have 2 pens, so this is 2x plus 9 pencils, so that's 9y, right, is equal to $24, right? So this represents our pair of simultaneous equations, right? Now the question says, calculate the cost of 12 pens and 15 pencils, right? So we need to solve this first of all to figure out what is x and what is y. What's the cost of 1 pencil and what is the cost of 1 pen? We need to work out that first, right? So here's what I'm going to do here. right? Now, what we could do, right, we can label both equations. That's usually what we do, label both of them. Call that equation 1, call that equation 2, right? And I'm going to use elimination in order to solve this thing here. What I'm going to do, that second equation, I'm going to multiply it by 2. So equation 2 multiplied by 2, you're going to end up with 4x plus 18y, right? And this is equal to 48, right? Let's call that equation 3 now, right? Now, what we have done, we've transformed the second equation to get this, right? So what we're really using now to work out this thing is this equation and this equation, right? So what I'm going to do, I'm just going to write back the 4x plus 3y is equal to 18, right? That's equation 1, right? And what we're going to do here, if I want to eliminate x, I'm going to subtract both equations. So 4x minus 4x is going to give me 0. 18y minus 3y, you're going to get 15y, right? And when I subtract this here, 8 minus 8 is 0, 4 minus 1 is 3. So therefore, y is equal to 30 over 15. So therefore, y is equal to $2, right? So I've just worked out what y is here by the process of elimination, right? Now, CSEC doesn't force us and tell us what particular method to use. They don't do that, right? All right, so you can use substitution, you can use elimination, doesn't really matter, right? So what I'm going to do now, I'm going to take this value for y, and I'm going to substitute it into any one of the equations, right? Let's use 1. So substitute y equal 2, right, into equation 1, right? So in this case, it's going to be 4x, right, plus 3y, but you know y is equal to 2, so it's going to be this. 4x plus 3 by 2 is equal to 18. So this is 4x plus 6. Right? So 4x is equal to 18 minus 6. And therefore x is 12 over 4. Right? So we just worked out the cost there. We know the cost of a pen and the cost of a pencil, right? So one of them is $3, one of them is $2, right? So we didn't answer the question as yet, by the way, because the question says, what's the cost of 12 pens and 15 pencils, right? X is 3, y is 2, right? So let's write that down first. X is 3. Right? So if I want to work out the cost of 12 pens, right? So it's going to be 12. Which one is the pens now? Right, pens is x. So this is 12 by 3 plus 15 pencils. Right? So 12 3s are 36 plus 15 by 2 is 30. So this is going to be $66. Right? So that's the total cost there. So you could get a question on simultaneous equations, right? They could give you it worded, like in this case here, or they can just give you the simultaneous equations, right? Right, so that is second question. Third question here now. We have a right angle triangle, right? And we have some lengths on it here. We have 200 meters, 180 meters. And the first thing we want to calculate the length BC, right? So that is this length here, right? Now, because it's a right angle triangle, we can use Pythagoras' theorem in order to work this out. Now, I normally tell my class, don't just learn our formulas. You need to know how to apply the formulas, right? So let's call this x here for now, right? If I want to use Pythagoras' theorem, I will say that x squared plus 180 squared, right, is equal to 200 squared, right? That's how you're going to use Pythagoras' theorem. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So we're going to solve this here. This is going to be x squared is equal to 200 squared minus 180 squared. So x squared is equal to, so 200 squared minus 180 squared, you're going to get 7600, right? So therefore x is equal to square root of 7600 right? And I'm getting 87.2. Right? So be prepared to answer any question involving Pythagoras' theorem. Right? Now, part 2 now, we want to calculate the angle ABC. Right? So we know what x is. X is actually 87.2. Right? And you want to calculate this angle here. Let's call that angle theta, right? Now, there are more than one way we can work out this angle because you have all the sides of the triangle. Now, for your exam, guys, please make sure you remember this. For any right angle triangle, we have so, ka, toa. So, in a right angle triangle, the sine ratio is opposite of our hypotenuse. That's what this is telling me. The cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, it doesn't matter which one we use here, but what I'm going to do, I'm going to label this here as my opposite, right? This side here, right, is your hypotenuse, right? The side opposite the 90. And then what you're left with is your adjacent, right? So we can use any one of the ratios if we want. If I use the opposite and hypotenuse, I can say that sine theta is equal to opposite over hypotenuse. So therefore, sine theta is equal to 180 all over 200, right? So sine theta that's 0.9. So therefore, theta is equal to arc sine 0.9 and you're getting about 64.2 degrees. Right? So that's my angle there, right? Right, so that's part A. Part B now, we have a transformation question. So the third question in your exam is going to be based on transformation, right? So we have two triangles. Well, sorry, we have, well, I don't know why I have three triangles here. It's really two triangles, A and B, right? Two triangles, A and B. Describe fully the transformation that maps A onto B, right? Look at A, look at B. What you all think that transformation is here, guys? What kind of transformation are we talking about here? All right. So some people saying rotation, right? But remember in the last two sessions what I said, right? When it comes to rotation, we have to say certain things. We have to say whether it's clockwise, anti-clockwise. We have to give the angle. All of those things we need to give. And we also need to give the center of rotation, right? Now, if you look at this carefully here, right? Yes, I agree it's a rotation, right? It is a rotation, right? Because the orientation has changed, right? Now, we can look at this rotation in two different ways. Some students might look at this and they might say, well, you know what? If we're going from A to B, this looks like a simple rotation going this way. Could be a clockwise rotation. Some students might look at it and they might say, well, you know what? I feel it's an anti-clockwise rotation. Either one of them is correct once you give the correct angle. So we can say a rotation of, in this case, it looks like 90 degrees, right? About the point, right? In this case here, this is a rotation about the origin, right? And you can double check that with your compass if you need to. So about the point, right? 0, 0, right? In a clockwise direction. So it's a rotation 90 degrees about the point 0, 0 clockwise, right? Now, instead of saying clockwise, some of you may have wanted to say anti-clockwise. If you said anti-clockwise, you must use 270 degrees anti-clockwise, right? So I saw some of you all saying anti-clockwise 270. Yeah, that's fine as well, right? Right, so that is, okay. The next thing we want to do, we want to reflect triangle A in this line here. X is equal to minus 2, right? Now, we did something similar yesterday, right? So, the first thing we need to do, we need to identify the line X is equal to minus 2. So, in this case here, let me get a line first. Now, the line X is equal to something, right, is always a vertical line, right? Right? So x is equal to minus 2 is a line that's around here. Right? And what I'm going to do, I'm going to reflect that triangle A in that line. So we did something like this yesterday. So this triangle here is actually 1, 2, 3 units in front of the mirror line. So this is your mirror line here. X is equal to minus 2. Yeah, it's minus 2, right? So what I'm going to do, I'm going to go behind the mirror line 1, 2, 3 units behind the mirror line, right? And we're going to complete this triangle here. So it's going to look like this, right? And it's how many units? 3 units. So it's going to be like this, right? So this here represents my triangle A when I reflect it in the line X is equal to 2, right? Now, these are easy questions here if you know what you're doing, right? So that is part 2. The next part, we want to do an enlargement now. All right, so we want an enlargement. The scale factor is 3, and the center of enlargement is 5, 6, right? So we're looking at an enlargement scale factor 3, and we're using the 0.56, right? So here's how I'm going to do this. Hold on, let me copy this across it. Right, I hope you all see my screen there, right? Now what we're trying to do, we want to do an enlargement, right? The scale factor is 3, so K is equal to 3, right? And also the center of enlargement was 5, 6, right? So the center of enlargement is 5, 6. Now how do we do that, right? So here's what you're going to do. The first thing we need to locate, where is the point 5,6? So 5,6 is up here. So that's your center of enlargement, right? Now, what you guys have to do in the exam here, you need to draw some construction lines. So start from the center of enlargement. And what we're going to do, we're going to draw these projection lines here, right? So it looks like this. I'm going to draw next one, passing through this point here, right? We're going to draw next projection line here. Right? Now, some students, they know that we have to draw these projection lines, but they still don't know how you're going to figure out where is this point going to be, right? Now, this is where your, there's in your geometry set, right? I know some of you all may have never used this in your geometry set, but there's something called a divider, right? One of them, right, we can put a pencil and draw circles, but there's another one where instead of drawing circles, it just has two pointy parts, right? You're going to make use of that when you're doing a question like this. So here's what you're going to do. Your center of enlargement was this point here, 5,6, right? So what I would do, I would open my divider, that's the one without the pencil, right? Open the divider so that I'm reaching one point on the triangle there, right? And then what I'm going to do now, I'm going to measure, because the scale factor is 3, you're going to do this. So that's 1, that's 2, right? Now you need to kind of mark on your diagram here where this is, right? That's here. And then we're going to go again, and we're going to go to 3, right? And you realize, wait a minute, I've just figured out where this part of the triangle is going to be. It's going to be right here. Right? So that's going to be the top of the triangle after it's enlarged, right? The next thing we're going to do now, I'm going to do it for this other point here, right? So you open the divider up to here, right? And then you're going to measure that 3 times basically. So that's 1 there already. There's the second one. Right? Now, some students, they use a ruler to measure. You could do that if you want, but a divider is the best way to do this, right? So you mark up this point here, right? So that's 2, and let's do it one more time. So notice I'm not adjusting the opening, right? I'm not adjusting the opening. So the next point here now is going to be right here, right? So as you can see, right, I'm actually drawing out this triangle. I'm seeing where I'm going to draw the triangle. We do it for the last one now. So put back your pointy part here. Let's open this now to this width here. So because the scale factor is 3, you already have 1 here, 2, right? Let's just mark it off, right? And we just need to do it one more time, right? And look at where it's landing. So it's landing here, right? So just like that, I know exactly where I'm going to draw this enlarged thing now, right? So all you do, you're going to join this to this, right? Join this to this, and then join this to this, right? And that's it. That is my enlarged triangle, right? That's my enlarged triangle here, right? Right? I see some of you all saying you never did this in school. Yeah. I have a lot of videos that you all can look at online, right? Where I do some of these constructions, right? Right? So that there is my that's my enlargement, right? So let's go back to the screen here now. Right, so that's the third part. We did an enlargement. The fourth part, we're on the grid. We want to translate triangle A using vector -4, 2. So -4, 2, right? That's your translation vector. So if you're going -4, you're going to go 1, 2, 3, 4 units to the left, and then you're going to go 1, 2 units upwards, right? So therefore, this here will represent the top of my triangle, right? So therefore, if I were to draw this triangle here, I'm just going to draw 2 units downwards. The base of the triangle is 3 units, so it's going to be here, right? And then we're just going to complete this here, right? Now I'm using this, I'm drawing this freehand here. Please use a ruler in the exam, right? So that's your translated triangle here using this vector, right? The -4 means you're going to move 4 units to the left, and then you're going to move 2 units upwards. That's what those numbers mean, right? So that is number 3, right? Let's move on. All right, question 4 is typically our functions question, right? So I have 3 functions here, f, g, and h. And the first thing we want to work out f of -2, right? So if you want to find f of -2, all you need to do is to plug -2 into that formula, right? So f -2, right? That is going to be 2 by -2 minus 3 all over 3 by -2 plus 1, right? Now you have to be careful with questions like these though. -2 multiplied by 2, you're going to get -4 minus 3 all over 3 by -2 is -6 plus 1. -4 minus 3 is -7, and then -6 plus 1 is -5. So the answer is going to be 7 over 5. Right? So that is part 1. Part 2, we want to work out a composite function here, gh of x, right? So basically, we did one like this either yesterday or the day before, right? You want to find a composite function. So, hold on, All right, so you want to get gh of x, right? G, right? So basically, what that means is that you are going to substitute. You're going to take the function h and you're going to plug that into g. That's what it means. So you're going to take h, which is all of this, and you're going to plug that for x into that function there, right? That's what it means. It's a composite function. So this is going to be 3 multiplied by 2x minus 3 squared minus 1. Now, this here is 3. Now, when I expand this here, right, when I expand this, I want you all to understand you are multiplying 2 brackets, right? Don't tell me the answer is 4x squared plus 9. That's not the answer. The answer here is going to be 4x squared, right, minus 12x plus 9 minus 1. So this is going to be 4 3s are 12x squared minus 36x plus 27 minus 1. So this is going to be 12x squared minus 36x plus 26. right? So that's my answer there. That's my composite function, right? Now the next part, they said state the value of x for which a function is undefined. Now, what you all need to remember for a question like this, right? 0 divided by any number is going to give me 0, right? If you take a calculator and take 0 and divide it by anything, you're going to get 0. However, if we take any number and you divide it by 0, you're going to get an error on your calculator, right? Or what we refer to as undefined, right? So in the case of this function f here, right, there is a value of x for which the function is undefined. All you need to do is to put the denominator, that 3x plus 1, just put that equal to 0 and solve for x. That's all you're doing. So 3x plus 1 is equal to 0. 3x is equal to minus 1. And therefore x is equal to negative 1, 2. Right? Right, so that is my value of x for which the function is undefined. The next part here, part 4, right? Now this particular question here, this is the hardest inverse we could get in the exam, right? I included this here so you get a feel for how to work it out. F of x to x minus 3 all over 3x plus 1, right? So you want to get the inverse of this function here. Now the procedure is the same. The first step in the process is to let y equal to whatever the function is. So this is going to be 2x minus 3. Right? So that's step 1, right? We let y equal to whatever the function is. The next step in the process is to interchange x and y. So you're going to put x is equal to, anywhere you see y, you're going to put x, and anywhere we see y, we're going to put, anywhere we see y, we're going to put x, and anywhere we see x, you're going to put y. So this is going to be 2y minus 3 all over, right? The next step in the process is to make y the subject of the formula. So what I normally tell students to do is to write this as x over 1. Why am I doing that? It allows me to cross multiply. So I can say x multiplied by this is equal to this multiplied by this, right? Now, the thing with a question like this is some people may get slightly different answers, right? So if I were to do x multiplied by 3y plus 1, so it depends on how the student rearranges their answers here, right? Now you're trying to make y the subject of the formula. On the left hand side here, we can remove the brackets. So you can say x by this, and you can say x by 1. So x by 3y will give me 3xy plus x, right, is equal to 2y minus 3, right? Now, what we're going to do now, we're going to carry all the y's to the left side. So I can write this as 3xy minus 2y all right, 3x minus 2y is equal to minus 3 minus x. And on the left hand side here, so this is one of those questions where if we're trying to find the inverse, factorization is involved. So this is going to be y, open brackets, 3x minus 2, right? And you're going to get minus 3 minus x. So therefore, y is equal to minus 3 minus x all over 3x minus 2. Right? So the inverse function, we're just going to make a statement here that the inverse function is given by this. right? Now, like I said, when you work a problem like this, right, some students, so if you come out the exam and you all had a question like this, there is a possibility that your answers may look slightly different. So some of you all may work the same question and you may end up getting 3 plus x, right, all over minus 3x plus 2, right? This answer is correct as well as this answer is correct. So keep that in mind. So don't get scared when you come out the exam and you, you see something else, right? All right, so what else we have to do here now? All right, so we have a coordinate geometry question here. So we have 2 points P and Q, right? And we have their coordinates. And the first thing we want to do, we want to determine the length of PQ. So there's a formula. We did a question like this yesterday, I believe, right? So length, and guys, they're not giving you these formulas, so you need to know them, right? So this formula here is x2 minus x1 squared plus y2 minus y1 squared, right? And we have to find the square root of this, right? This is the formula to find the length if you know two coordinates. One of the things that you should always do is to label your coordinates, right? Make sure and label your coordinates. So let's call this x1, y1, right? Let's call this x2, y2, right? Always label your coordinates before you do anything. Then what we're going to do, we're going to substitute those numbers into the formula. So if it's x2 minus x1, it's going to be 3 minus 2 squared plus 5 minus 6 squared. Right? Now, 3 minus 2 is the same as saying 3 plus 2, so that's 5 squared. Right? Plus 5 minus 6, that's 11, so that's 11 squared. Right? So when we work this out here, this is going to be 5 5s are 25 plus 121. Second function, square root. And you're going to get about 12.1. Right? So I see some people get 12.1. Great. Right? Right, so that's part one, that's the length. Now I didn't do a question yesterday on midpoint, right? So if you want to find midpoint, guys, there's a formula for midpoint. Again, this is not on your formula sheet. So the midpoint formula is this: x1 plus x2, right, all over 2, comma, y1 plus y2, all over 2. Right? It's a coordinate. So that's why you see a comma in the middle of this formula here. So we're going to take the two x values, which in this case is minus 2 plus 3. You're going to divide that by 2, comma. Then you're going to take minus 6 plus 5. You're going to divide that by 2, right? And minus 2 plus 3 is 1. So this is going to be a half, right? And minus 6 plus 5 is minus 1. So this is going to be minus a half. So therefore, this here represents my midpoint. It is a half minus a half, right? Alright, so the last part of the question, we want to determine the equation of a line which is parallel to PQ, but it passes through this point 41, right? Now, visually, I want you to understand what's happening here, right? So you have a point P, and you have a point Q, right? Now this is just for illustration purposes, and we have this line here, right? We want to work out the equation of a line which is parallel to PQ, but it passes through the point 4, 1. So it's as if we have a point here, right, which is given by 4, 1, right? And what the question is asking me to do is to work out what is the equation of this green line here, right? It's parallel to PQ, but it's passing through 4, 1. So I want you to understand this here is what they're asking us for. What is the equation of that line? So the first thing you'll need to do is to find the gradient of PQ, right? And then once you have the gradient of PQ, you're going to use this information here in order to come up with the equation of that straight line. So let's start by first working out the gradient of PQ. So P is minus 2 minus 6. Right, Q is 3, 5. Right, the point T here is 4, 1. Right, so step 1, we need to find the gradient of PQ. There's a formula to find gradient, right? And that formula is not given to you in the exam as well. It's y2 minus y1 all over x2 minus x1, right? That's the formula to find gradient. So again, make sure these points label x1, y1, x2, y2, right? And then all we're going to do now, we're going to substitute into this gradient formula here. So y2 is 5. So this is 5 minus 6 all over 3 minus 2. So that's 6 and 5, 11, and 3 and 2 is 5. So this here represents the gradient of PQ, right? Now, let me just call this green line, I'm just going to call it L2, right, to help us answer the question. Let's call it L2. So the gradient of L2, right, has to be equal to that same 11 over 5 because those lines are parallel, right? Those lines are parallel, so we expect the gradients to be the same, right? Right, I really not monitoring the chat, guys, so I'm hoping you all hold on, All right, I'm just trying to see, I know some of my students are here, all right? So if any of my personal students here want to be moderators, just let me know in the chat, right? Right, so too many messages, so I'm going back to doing the paper, right? So anyways, so the gradient of L2 is going to be 11 over 5, right? But the equation of any straight line is given by y is equal to mx plus c, right? You all need to know this, right? The equation of any straight line is y equal mx plus c, but the equation of this line, right, the gradient, sorry, is 11 over 5, right? X plus c. Right? Now the thing is, the only thing missing here for us to complete the question is to figure out what the c is, right? Now this is where the 4, 1 is going to come into play. That's an x coordinate and this is a y coordinate. So we're just going to say when x is 11 over 5, right? Y, sorry, what am I saying? When x is 4, right? Y is 1, right? So actually I was doing this with my AdMaths class today, my Form 4 AdMaths class, right? So we're going to substitute these numbers into this equation. So 1 is equal to 11 over 5 by 4 plus c, right? So therefore c is equal to 1 minus 44 over 5. So therefore c is equal to minus 39 over 5. Right? So the equation of the line that we're looking for here is simply going to be y is 11 over 5, x minus 39 over 5. Right? If anybody worked it out from my class, just let me know if that's the correct answer. Right? Right? Okay. Sarah says, yeah. All right. So yeah. All right. So that takes care of question 4, I believe it was. Question 5, right? We have the diagram shows an incomplete bar chart or bar graph, sorry, as this bar graph here. It shows the scores obtained by Sana in 6 maths exams, right? The maximum possible score in each exam is 15 and the total score in all the exams is 59. She scored twice as much in exam 5 as she did in exam 2, right? Now you guys have to be able to take that information now and translate that in order to complete this thing here, right? So the total score in all 6 exams is 59. So the total is 59. Right, so we have 6 exams here and we have the scores in all of them, right? Except we're missing exam 2 and we're missing exam 5. But in the question says that she scored twice as much in exam 5 as she did in exam 2, right? So whatever this is, we don't know what it is yet, right? Whatever that is, she would have scored twice as much in exam 5, right? Now, for those of you trying to figure out, well, how are we doing that, right? Well, you know the total score is 59. So what you could do is to take this score, add it to this score, add it to this score, add it to this score, right? So that is 7. So watch what I'm going to do here. That's going to be 7 plus 14, right? Plus 15, right? Plus 5, right? So that is 7 plus 14 plus 15 plus 5, and you're going to get 41, right? So for all the bars that there, we have a total score of 41. So therefore the missing bars will be 59 minus 41. So 9 take away 1 is 8, 5 take away 4 is 1, right? So we have 18 scores to fill in exam 2 and exam 5. But the thing is, let's say we have X score in exam 2. In the 5th exam, it's going to be twice as much, because that's what they said in the question. They said she scored twice as much in exam 5. So what I'm going to do, I'm going to come up with a little equation here. So when I add exam 2 score plus exam 5 score, which is twice as much, right? When I add that up, I should get 18, right? So this here is going to equal to 18. So therefore 3x is equal to 18. So therefore x is equal to 18 over 3. So therefore x is equal to 6, right? So in order to complete this here now, all I need to do for the second exam, we're going up to 6. Right? So that's 6 here. And then we want, for exam 5, since it's twice as much, it's going to be 2 by 6. So this is going up to 12. Right? So this is our completed bar chart here using the information, right? Using the information that they give us here, right? So the ratio is 1 to 2, or it's twice as much, right? Right, so we completed the bar graph. That's what I wanted wanted us to work out, right? The next thing we want to do, we want to calculate what's the mean in the 6 exams, right? So remember, right, now the symbol for mean, some of you all may not use the symbol here, but that's the symbol for mean. It's an X with a small bar on top of it. We just need to add up all the scores and divide by how many exams we have. We have a total of 6 exams, so we're just going to take the scores for each exam. The first one is 7, then 6. So it's going to be 7 plus 6, right, plus 14, 15, and 12. Right, and what else are we missing here? 5. Right, so these are the scores in each of the exams, and we're just going to divide that now by 6, because we have 6 exams in total. So that's going to be, oh wait, I just realized we didn't have to do all of that because they told you in the question that she scored 59 in all the exams. So I didn't have to go and work out all of that. They told me that already here. So 59 over 6. And you're going to get 9.83. So that's her average there, right? Or her mean. Right? Somebody's asking if to put 9.83 or 9.8. If you put 9.8, you'll still get the marks, right? If you put 9.83, you'll still get the marks, right? So you can go to 1 decimal place or 2 decimal places, you'll still get the mark, right? Let's see what else we have here now. All right, so the time, T minutes taken for each of 80 people to travel to work is recorded. The table shows the information about these times. So we have time in minutes taken by 80 people to travel to work, right? And what we want to do, right? That's all. I feel I missed out a piece of the question here. But basically, we need to complete the cumulative frequency table, right? Now, if you all remember how to do that, we start with the first frequency. There's nothing before, so it's going to be 2. When I'm working out for the second row, I need to add 12. So this here is going to be 14, right? Then I'm going to add 19 more, right? That is going to be 33, right? Then we're going to add 29, right? So that's 33 plus 29. You're going to get 62. Then we're going to add 14 for the next row, right? So plus 14, you're going to get 76. And then we're going to add 4 to the last row, and you're going to get 80, right? Now, whenever you're trying to complete a cumulative frequency table, right, if this last number here is not equal to the total number of whatever they're talking about, then you have a problem, right? It means there's a mistake somewhere, right? There's a mistake somewhere, right? Right? All right, now what we want to do here now. Okay, so we want to draw a cumulative frequency curve, right, using the data here, right? So hold on. I'm just going to pull the data across here so I can draw the curve. All right, so now the thing is, CXC has a tendency these days to give us our intervals to look like this, right? They have a tendency to do that. Now, for this first row here, remember when you're plotting cumulative frequency curve, we use upper class boundary. Now in this case here, your upper class boundary is actually 5, right? So you need to plot 5 against 2, because 2 is the cumulative frequency. So here is your first point that we plot in here, right? That's our 5, 2. For the second row here, your upper class boundary is 10, and you're plotting 10 against 14, right? So this is 10, this is 12, 14, that's here, right? Next one here, your upper class boundary is 15, and you're plotting that against 33. So this is 30, 32, this here is 33. The next one here is going to be 20 against 62. So 20 against 62 is going to be here, right? Then the next one is going to be 25 against 76. So 25. Okay, so I'm running out of space, right? Hold on. Right? I need to shift back the table a little bit, right? Right, so what's the last one I plotted here? 20 against 62. Then we have 25 against 76. So 25 against 76 will be 70, 72, 74. That's here. And the last one is going to be 30 against 80, right? So you could be asked in the exam to complete a cumulative frequency curve and then draw the curve, right? In this case here, please don't take your ruler and join the points. You have to draw a smooth curve, right? It's kind of hard for me to draw this smooth curve here, so bear with me. Right, so in the real exam, you're going to have to try your best to draw a smooth curve that kind of passes through all the points, right? So that's my cumulative frequency curve here, right? So that takes care of question 5. That's all they wanted, right? Right, question 6. So we have a diagram here and it's showing a swimming pool of length 30 meters, right? A width of 25, right? And a cross section of the pool ABCD, right? So the length of the pool here is 30 meters. So that's here, right? And we know one AD is 25, right? One second, let me just make sure I say any correct thing here. Yeah, a little typo here, right? But 80 is 25, right? No, hold on. That's not. Let's see. Okay, now I think we're okay there, right? So it's a pool, right? If you all ever been to a pool, there's usually a deep part of a pool and a shallow part of a pool, right? Right? Let's see what's happening here now. So the first thing we want to calculate the area of the trapezium ABCD. So guys, ABCD, that's this trapezium here, right? You guys need to know how to find the area of a trapezium. So the area of a trapezium is given by this formula. A half the sum of the parallel sides multiplied by the width or the height, right? In this case, it's going to be a half. Right? Now the parallel sides they're talking about here will be this side and this side here. So that 2.5 and the 1.2. So it's going to be 2.5 plus 1.2, right? Multiplied by the spacing between them, right? Now the spacing between the two parallel sides here is going to be 30. So So this is going to be 2.5 plus 1.2, right? Multiply by 30, multiply by 0.5. So I'm getting 55.5, and this is meters squared, right? Let me double check that. 2.5 plus 1.2. Yeah, so that's 55.5 cm squared, right? I don't know if anybody worked that out before, right? Right? See somebody saying I missed a question. Yeah, I feel I missed a question there, right? I'll come back to it if there's anything, if I have time, right? I feel I didn't copy the whole question properly into these slides, right? The median and the probability, sure. Right? So that's part B, right? We calculated the area, right? Calculate the area of the trapezium. The next part here, calculate the volume of the pool. Now, to work out the volume of this pool here, right? Now this volume or this pool here is a prism. So all you need to do, a prism is equal to, the volume is equal to A by the length. So in this case here, the cross-sectional area is the trapezium, which is the 55.5, multiplied by the width in this case, which is 25. Right? So that's 55.5 multiplied by 25. And I'm getting 1387.5. And this is volume, so it's going to be meter cube. Right? It's going to be meter cube. Right? How do you know it's a prism? So guys, a prism, right? A prism is basically a solid shape, right? That has a uniform cross-sectional area. If you look at this pool here, right? The cross-sectional area is a trapezium. So no matter how we cut this solid, we are always going to get the exact same cross-sectional area. That's how we know it's a prism, right? So you can have things like triangular prism. You can have a cuboid is also a prism, right? Right, 1387. Right, so Ivana says, yeah, okay, cool. Right. The next thing here now, we want to calculate the number of liters of water in the pool when it's full. Right. Now you guys have to be able to convert from meter cube, right, into liters. Right. Now here it is. Now 1 liter, right, or just now, 1000 cm cube, right, is actually equal to 1 liter, right? 1000 cm cube is actually equal to 1 liter, right? So could you all work out for me how many liters you all think this is? Right, I've seen some people have some answers here, right? Now here's what you need to do here. Now, 1000 cm cube is 1 liter. But if you notice something here, you worked out this volume here and you got meter cube. Now let me just show you guys something here quickly. Some of you all may have never seen this before, but let me just show you something here. So we know the volume of water in the pool, right? But we know that volume in meter cube, right? 1000 cm cube is 1 liter, right? Now here's what I normally show my class, right? So 1 cm multiplied by 1 cm, right? Some people like to learn our formulas, I don't, right? if I want to 1 cm cube, right, is equal to 1 cm by 1 cm by 1 cm, right? Now, if you want to convert centimeters to meters, we divide by 100. So this is 0.01 meters multiplied by 0.01 meters multiplied by 0.01 meters, right? Now, if I multiply all of this here, right, you're going to get this 0.12345 meter cube, right? So this is a nice conversion, right? I'm missing something here. 1, 2, 3, 4, 5. Yeah, right? So 1 cm cube is actually 0.000001 meter cube, right? Now the pool has a volume of 1387.5. Right? Meter cube, right? That's the volume of the pool here. So what I'm going to do, right, based on this conversion here, 0.00001, 1, 2, 3, 4, 5 meter cube, right, is actually 1 cm cube, right? So if I want to convert this here, meter cube, into cm cube, all you're going to do, you're going to say 13,875. You're going to divide by this number here. Right? Right? And you're going to get a very large amount of cm cube, right? Right? I'm going to write this answer in standard form because it's very large. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I don't know if any of my students did this, right? How many zeros I put there? 1, 2, 3. Yeah, my bad, right? So let me just double check this. 1387.5 divided by 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that seems to be correct there, right? Yeah, I put in a 0, guys, right? All right, now what's happening here now is that this here is the actual volume of water in cm cube in the pool, right? Now 1000 cm cube is 1 liter, right? So therefore, this big number here, if you're wondering what I'm doing here, I'm writing this in standard form here, right? Because the number is so large, right? So all I'm going to do, I'm going to take that number and I'm just going to divide that by 1000, right? So divided by 1000, and you're going to get this. This is the amount of liters you're going to get. 1387500, right? That's the amount of liters of water in that pool, right? Right? So this question a little harder here, right? All right, so part E now, right? We know the length of AB, right? AB is 30.03, right? Where is AB? That's this length here, right? That's here. So here is 30.03, sorry. Right? Now the inner walls of the pool right, is to be painted with water or waterproof paint, right? Calculate the total surface area that has to be painted. Now, whenever you are given a solid figure in the exam, you could be asked to find volume or you could be asked to find surface area, right? Now, the thing is, what I need you to do is when you're looking at surface area, so we're concerned about painting the inside of the pool, right? Could you guys tell me in the chat how many faces do we have to paint? How many faces of the pool do we have to paint? So most of you all saying 5, right? Most of you all saying 5. Let's see if that's true or not. So look at all the faces, right? Let me use a different color here. So the first face, right? You will have this face here, that's 1, and you have this exact same face here, that's 2. But we already worked out that area. That's this area here, right? So that's this. Those two faces are identical. You will also have to paint this face here. That's a rectangle, right? You're going to have to paint this face here on the inside. And then you also have to paint the floor inside here. So that's a total of 1, 2, 3, 4, 5. Whenever you are asked to find surface area, my suggestion to you is to first figure out how many faces do you have to look at, right? If you don't know the number of faces, then you'll work it out wrong, right? So in this case here, you already worked out the two rectangles, right? Sorry, the two trapezia, right? You worked out those already. So you have to take this and multiply by 2. That'll take care of this face as well as this face here, right? The next thing we need to do, we need to take care of, we have 3 rectangles to take care of, right? One of them is going to be 25 by 2.5. I'm just going to work it out up here, right? 25 by 2.5, right? That's the one, that's this one. If we look at the base of the pool, right, that is going to be, what we have there? That's 30.3 by 25. Right? Plus, we have this face here, which is 25 by 1.2. Right? Plus, we have 2 of the trapezia to work out as well, which is 55.5. Right? So the total area that you have to paint on the inside of the pool is going to be right? I don't know if anybody worked this out for my class here. I don't know if you're getting this. 961 meters squared by chance. Anybody from my class actually worked out the area? Yeah, again 961 too, right? That's something. Right? You all have a good point. You said the inner walls, right? Doesn't include the floor, right? Right? Swizzleman, yeah, you have a good point there, right? So I'll take note of that, right? When I adjust this question accordingly, right? right? Now the difficulty of this question, it's a little longer than what it should have been, right? So I'm going to leave this question here for now, right? I'm going to leave this question here for now. I'm going to move on to question 7, right? Which is the investigation question, right? We're going to move on to the investigation question here. So the diagram below shows a sequence, right? Each figure consists of white squares and gray squares. The side of each square is of unit length, right? So we have 3 figures here. And what we want to do, we want to complete or draw the 4th figure in the sequence. Now you all need to analyze whatever sequence they give you. You need to look at it carefully, right? So if you notice in all of these diagrams here, right, the first column is filled with gray squares. And then what we're doing here, we're just going across the diagonal, right? We're going across the diagonal in each diagram. So if I wanted to complete this here, right, what I'll do, I'll shade everything going on here, right? And then we're going to go diagonally. Right? I don't have time to shade all of it, right? But basically this is what it is, right? So this is my figure 4 here in this particular sequence, right? Right? That's basically what's happening in all the diagrams, right? So that's figure 4. Now, in the table below, right, G is the number of gray squares, P is the perimeter of the shape formed by the gray squares, and T is the total number of white and gray squares. Study the pattern and complete the table, right? Now, if you know what you're doing in a question like this, you can gain a lot of marks from this question here, right? In this case here, right, we don't have, well, we have figure 1, we have figure 2, figure 3. Figure 4 is what we just drew, right? So the total number of gray squares, we just need to count it. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So I'm getting 13 gray squares here. So this is going to be 13, right? The perimeter, right? If we look at the diagram here, the perimeter of the 4th figure will be 1. So I keep going like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Right? Let me see that making sense. I'm getting a total of 38. Right? That's what I'm getting here. Now the total number of squares is simply going to be the number of gray squares, right? But in this case here, gray squares plus white squares, right? If I look at this figure here, we have 1, 2, 3, 4, 5, 6, 7. So therefore, it's going to be 7 by 7. That's the total number of squares. So this is going to be 49, right? So that's figure 4, right? Now what I normally tell my class to do is to work out what is the formulas for figure N. Right? Do that first before you figure out anything. So in this case here, let's see what's happening. When I jump from here to here, right, I'm adding 2. When I jump from here to here, I'm also adding 2. And when I jump from here to here, I'm also adding 2. Those types of sequences are easy to figure out, right? That 2 needs to appear in your formula. So it's going to be 2n. And we're going to test with this first one here. If this is figure 1 and this answer is 7, it's going to be 2n plus 5. That's what the formula is going to be. You can double check it with figure 2. 2 by 2, that's 4. 4 plus 5, you're going to get 9. Now when we do the second figure now, the second column, sorry, when you jump from here to here, you're adding 6. Jump from here to here, you're adding 6 as well. And jump from here to here, you're also adding 6. So what that tells me, because I keep adding 6, that 6 has to appear in the formula somehow. So let's start with 6n. Now if you want to get 20 here, right, and I plug 1 into my formula, it has to be 6n plus 14, right? You can try it with the second figure. If I put 6 2s at 12, 12 and 14 will give me 26, so it works out well. So that's my formula there, 6n plus 14. When you look at this here, you will notice that all of these numbers here, those are square numbers, right? So how do I take figure 1 and how do I end up with 16, right? So if you want to get 16, it means that it's going to be n plus 3, and I need to square that, right? Because 1 plus 3 is 4. 4 squared is going to give me 16. If I try it with figure 2, it'll be 2 plus 3, that'll be 5. 5 squared will give me 25. So therefore, those are my formulas for the nth two, right? Hope that making sense, right? Okay, so now, what we want to do, we want to complete the table. So for this row here, you know the number of gray squares is 17. So what you'll do, you'll take 2n plus 5, right, and put that equal to 17, and you can work out the figure number from that, right? So this is going to be 2n is equal to 17 minus 5. So 2n is equal to 12. N is equal to 12 over 2. So n is equal to 6, right? So this corresponds to figure 6. If you want to work out the perimeter will be 6 by 6 plus 14. Right? So that's 6 is 36 plus 14. And you're going to get 50. So this here is going to be 50. You want to work out the total number of squares. So it's going to be 6 plus 3 squared. So that's 6 and 3, 9. 9 nines are 81. So this here is going to be 81. Right? So that's figure 6. Those are the numbers for figure 6. If you want to work out for this one here, we have a total number of 121 squares. So you're going to put n plus 3 squared is equal to 121. So n plus 3 is equal to the square root of 121, which is 11. So therefore n is going to be 11 minus 3, that's going to give me 8. So this corresponds to figure 8, right? So if you want to work out the total number of gray squares, we plug 8 into our formula. That 8 2s are 16. 16 and 5, you're going to get 21. And then if you want to work out the perimeter, it's going to be 6n plus 14. So that's going to be 8 by 6 plus 14. And you're going to get 62. Right? Somebody's asking, how do we get the 14? Right? You see, once you find the common number that you keep increasing by, you know that in this case here, for the perimeter, we keep adding 6. That tells me that 6 has to appear in the formula. There's a 6n in the formula. So what we're going to do, we're going to check to see if I plug 1 into the formula, what do I need to do in order for me to get 20 as my answer? 6 by 1 will give me 6. How much am I missing? I am missing 14 in order to make up the 20. That's where the 14 came from, right? Somebody says the n plus 3, right? So for this one here, right? For this column here, you'd realize that you have 16, 25, 36. Those are all square numbers, right? But the thing is, those numbers have to relate to whatever the figure number is. Now, to get 16, right, 4 squared will give me 16. But I have figure 1 here, right? So what I need to do, that figure needs to appear in the formula. So therefore, if I put the figure number n here, and I intend to get 16, I need to add 3 to this in order for me to get 16. Because 1 plus 3 is 4, so 4 squared is going to give me 16, right? These questions, they are kind of, you have to reason out certain things, right? You have to reason out certain things. Right? So that's number 7. How many white squares are in figure 12? Right? How many white squares in figure 12? So figure 12, that means n is equal to 12. So the first thing we should do is to figure out what's the total number of squares we have. So the total number of squares is given by this formula here, n plus 3 squared. right? So this is the total number of squares, n plus 3 squared. So if we plug 12 into this formula, it's going to be 12 plus 3, right, squared. So that's going to be 15 squared. That's 225. So this is the total number of squares that we do have, total, right? We're trying to figure out the number of white squares. We need to figure out the number of gray squares we have. If you go back to the table, there is a formula for the number of gray squares. It is 2n plus 5. So this is going to be 2n plus 5. That's the total number of gray squares. So this is going to be 2 by 12 plus 5, right? 2 12s are 24 plus 5, that's 29. So I know how much gray squares I have, and I know what's the total number of squares. So the number of white squares is simply the total minus the total number of gray squares, which is 2, well, hold on, It's 225, not 222. Right? Great. 29. Right? So we have a total of 196, right? 196. Right? So that's number 7. Question 8, right? Moving on because time kind of running out. We have a function here. It's a quadratic function, right? And we want to complete this table. This is something that you all can get tomorrow, right? All we need to do, right? We need to substitute. If we want to complete this table here, we need to substitute into that formula, right? So I'm just going to do the first one, which is 2 plus 5x. So that's 5 by minus 1 minus 1 squared, right? So this is going to be, so this is f of minus 1. So that's going to be 2 minus 5 minus 1, right? 2 minus 5 is minus 3. Minus 3 minus 1 is minus 4, right? Then we need to work out f of 2. So this is going to be 2 plus 5 2s are 10 minus 4. So 10 minus 4 is 6 and 2. This is going to be 8. Right? Then we need to plug 3 into the formula. So that's 2 plus 15 minus 9, right? So that's 17 minus 9. So this is going to give us 8, right? And then the last one, we had to plug 6 into the formula. Right, so that's 2 plus 6 5 is 30 minus 36. Right, so this is going to give me minus 4. Right, so you could be given something like this tomorrow where we have to complete a table like this. Right, so in this case here, right, I have a completed table. Right, and the next thing we want to do, we want to draw this graph here. Right, so let me get. Right, so we could be asked to draw a quadratic graph tomorrow, right? Complete a simple table like this. So we plot all the points, right? Minus 1, 4, right? That's here, right? 0, 2 is already plotted. 1, 6 is already plotted. So we have 2, 8 and 3, 8 to plot. So 2, 8 and 3, 8 is here. Then we have 4, 6 already plotted. 5, 2 already plotted. And we have 6 minus 4. Right, 6 minus 4, right? Now, what we need to do is to be able to draw a smooth curve through these points, right? Now in the exam, you have to try your best to draw the best smooth curve that you possibly can. Right? Again, this is a little hard for me to draw. Right? So this here is my quadratic, right? Please don't use your ruler to just join the points. You have to draw a smooth curve as best as you can, right? That's what you need to do for a question like this, right? Next thing we want, right? So we draw it. We want to state the equation of the axis of symmetry. Now if you go to the graph here, right? Now your axis of symmetry is that vertical line, right? That if I were to fold the graph paper along that line, right, the graph on the left is going to equal or line up exactly with the graph on the right hand side, right? So what we're looking for is our axis of symmetry. So basically it is this line here, right? This is our axis of symmetry. It's a vertical line that if we fold the graph paper along this thing here, right, it's going to line up exactly on the left and right. Now this vertical line passes through this point here, which is 2.5. So you see when CSEC asks us for the equation of the axis of symmetry, you're going to put that. X is equal to 2.5, or you could put 2.5. Right? That's the answer there. State the coordinates of the maximum point. So the maximum point, you need to go to the graph, and you're going to try to read off this maximum point here. Now your answers are going to vary depending on how you draw the graph, right? So my highest point there looking like about maybe 8.2. I'm just saying 8.2. So this point here could be 2.5, 8.2, right? So that's my maximum point. You're reading that off from the graph itself, right? So this is 2.5, 8.2, right? Now, we have a line here, right? X plus y is equal to 7. We want to state the coordinates of the x-intercept and the y-intercept, right? The first one, the y-intercept. So, at the y-intercept, right, x is equal to 0. You all need to remember that. If you are given an equation and you want to figure out what is the y-intercept, just plug 0, x is equal to 0 into the formula. So, this is going to be 0 plus y is equal to 7. So therefore y is equal to 7. So therefore the y-intercept is going to be 0, 7. That's the y-intercept. If I want to work out what is the x-intercept, right? Now the x-intercept occurs when y is equal to 0, right? When y is equal to 0. So for this one here, you're going to put x plus 0 is equal to 7. So therefore x is equal to 7. So therefore this point here is going to be 7, 0, right? So I've just worked out the x-intercept and the y-intercept. Next thing we want to do here, we want to draw this line. So to do that, all I need to do is to use this point and this point here in order to draw the graph, right? So 0, 7, 7, 0. So 0, 7 is here and 7, 0 is down here. And because we know it's a straight line, right? Just borrow this here. You're going to take your ruler and you're going to draw a line that does this. Right? So this is my line x plus y is equal to 7. Right? That's what that line is here. X plus y is equal to 7. Right? And then the last part, state the solution to this pair of simultaneous equations, right? Now you can solve a pair of simultaneous equations graphically if we know where the two graphs intersect. So all we need to do here, guys, we just need to realize that it's going to cut here and it's going to cut here. So the solutions, right, will simply be those coordinates there. So this first coordinate here is going to be 1, 6, right? So therefore that tells me that when x is 1, y is equal to 6. That's one solution. And this second point here is 5, 2. So therefore this solution is x is equal to 5 and y is equal to 2. Hope that kind of making sense, right? Right, so that takes care of question 8. Let's move on to question 9 quickly. So we have ABCDE lies on a circle, right? Angle BCD is 100 and ABE is 35, right? And we have two lengths which are equal, right? Let's see what we want to work out. The first thing we want to calculate is angle P. Angle P. How are we working out angle P here? Right? I don't know if you all seen it here, but this angle P here, right? This angle here has to actually be equal to 35 degrees, right? Because this line AE here, right? That's a chord. And when the chord forms an angle at B, you get 35. And if we take the same ends of the chord and we go to D here, we end up with angle P. So that's 35 as well, right? So angles in the same segment are equal. That's what we're doing there to work out P. Angle Q. Which one is Q now? So this one here is angle Q. What are we doing here? Any ideas for Q? All right, now here's what I'm going to do. I'm going to put in angles that we should know, right? Based on the fact that this length here is equal to this length here, right? I know that this angle here has to be 35 as well, right? So this angle here has to be 35, right? This angle here has to be 35. What else do we know? Right? Well, here what? I'm going to work out angle R because I can work out angle R one time, right? Because I have a cyclic quadrilateral here. A, B, C, and D. That's a cyclic quadrilateral. So if this is 100, I know that R has to be 180 minus 100, right? And that's going to be equal to 80, right? So I'm just working out all the angles that I can work out one time, right? What else? All right. So now I know that this angle here, this whole angle here, right? This whole angle here, right? Let's call that blue angle, right? That's actually 80 plus 35. So this is 115, right? That's 115. How is that going to help me? Will it help me? Right? I'm just trying not to make it too complicated, but it seems to be getting complicated, right? Somebody said AED. Right? Yeah, somebody has a suggestion there, right? Yeah, you can do that. You can also work out, you can actually work out AED, right? Because, just now. I want to use a different color here, right? All right, this whole angle here, this green angle here, you can work that out because you have a triangle there, right? And you know two angles is 135. So that angle there is going to be 180 minus 35 plus 35. All right. So this is 110, right? All right, so if that's 110, right, we have another cyclic quadrilateral in play there. So we can say that Q plus 35, right, plus, right, 110, that should equal to 180, right? So therefore Q is equal to 180, right, minus 110 minus 35. Right, so angle Q is 35 degrees as well, right? Angle Q is 35. Right, actually we didn't have to do all of that, yes, because what we could have done is this angle here, and this angle here, they're in the same quadrant, right? So Q has to be equal to the same 35 degrees. So we didn't have to go through all of that actually, right? So we know Q, right? We know P already. We already worked out R already, right? The only one we're missing is S, and S will be equal to all right. So this angle here is the same as angle S, right? That angle is the same as angle S, and what we could do, so this here is S, right? So P plus S, right, is equal to, or not equal to, P plus S plus 115, right, is equal to 180, right? I'll give you all a hard question here, baby. Right? So P is 35, so 35 plus S plus 115 is equal to 180. So we could work out S, right? S is simply going to be 180 minus 115, right? Minus 35, and you're going to get 30 degrees, right? So that's my angle there, right? That's my angle there. Right? Somebody's asking where the 115 came from, right? That 115 came from when we added this 35. We know that angle is 35 here, right? And we also know that this angle R here, right, is 180 minus 100, right? Right? Yeah, so I know you're all getting tired, so let me just breeze through as fast as I can, right? Let's jump on to this one here now. So this one here, we have A, B, and C are points on a horizontal ground, and we have a vertical pole of height 15, and it's located at the point B, right? So we have A, B, and C, right? And we have a vertical pole 15 meters at B, right? So you have a pole, there's a pole here, right? There's a pole there. We have some dimensions. So the first thing we want to calculate the angle ACB, right? ACB, right? That is this angle here, right? Now, in question 9, most of the times we either have to use the sine rule or the cosine rule, right? Now, in this case here, what we could do, if you want to work out this angle, let's call that angle theta, we could actually use the sine rule because you have a length and we have the angle opposite. we also have a length here and the angle opposite as well, right? So we can use the sine rule to work out that angle theta. So we can say 48, right, over sine theta is equal to 95 all over sine 35, 135, sorry. Right? So once we're using the sine rule, we know we're going to have to cross multiply. So we're going to say this by this is equal to this by this. So therefore, 95 by sine theta is equal to 48 by sine 135. Right? So therefore, sine theta is equal to 48 by sine 135 all over 95, right? So sine theta is equal to right, I'm getting 0.357. So therefore theta is equal to arc sine 0.357 and this here is going to be 20.9 degrees, right? Right, when you guys given your angles to give your angles to 1 decimal, please. Right, please do that. Give your angles to 1 decimal, please. Right. So that's the answer for that part there. Now the bearing of C from B is 102. The bearing of C from B. So the bearing of C is 1. Right. So this angle here. Right, this angle here is 102 degrees, right? The bearing of C from B, so you would have had to draw a north line at the point B and measure clockwise, 102 degrees, right? Determine the bearing of A from C. You want the bearing of A from C, right? Now let me just put in this angle here one time. So this angle we just work out here is 20.9. Right? Now we want to know the bearing of A from C. So what we want this whole angle here. Right? We want that whole angle there. Well, this is not too bad, right? Because if this is 102, right? If that's 102, you can actually work out this angle here, right? Because you have a north line and a north line, so they're parallel. So this angle here is 180 minus 102, right? And this here is going to give us 78 degrees, right? So, right, so that's 78 degrees here, right? So if you want to get angle, that bearing there, that angle there, right? This bearing here is simply going to be 360, right, minus, we need to remove the 78, right? And you need to remove the 20.9, right? When you work this out here, this will give us the answer we're looking for. So 360 minus, open bracket, 78 plus 20.9. And you're going to get 261.1. Right? And the next part, calculate the angle of depression of the point E from the top of the pole at B. So let's draw a side profile here. So this is the point B here, right? The pole was, how tall was the pole? The pole was 15 meters high. So this here is 15 meters high, right, as a pole. And the point point E. Right, where is E? Right, now we're gonna draw this like this, right? This is A here. This is B. (15 meters), right? And the distance between B and A is 48 meters. So this 48, right? And let's draw a line from the top of the pole to the point A. So you want to work out the angle of depression of the point A from the top of the pole. So angle of depression, right, is measured this way. That's your angle of depression, right? So what I can do, that angle here is actually equal to this angle here, right? So we can simply use tan. So tan theta is 15 over 48. So tan theta is 0.31. So therefore theta is equal to arctan 0.313. Right, so this here will be our angle of depression, right? About 17.4 degrees. All right, guys. I know you're all getting tired. I know you have exam in the morning, right? So let's see if I can wrap up. Let's see if I can wrap up one more question here, right? All right. So you want to work out. We have two matrices here, P and Q, right? And you want to work out P squared plus Q, right? Now P squared plus Q means P multiplied by P, and then you're gonna add that to Q. That's what P squared means, right? So this means that we're going to work out 1 minus 2, 1, 2, right? And you're going to multiply that by 1 minus 2, 1, 2, right? And then you're going to add that to whatever Q is, which in this case is minus 1, 1, 0, 4, right? So row by column, right? That's how we're working this out here. So this row multiplied by this column here, first of all, right? So that's going to be 1 by 1 is 1. 1 minus 2 is going to give me minus 1. So that's the number we're going to have here. Then we're going to take this row and multiply by this column, right? So that's going to be minus 2, right? Minus 4. That's going to give me minus 6, right? Then we're going to take this row and you're going to multiply by this column here. So that's 1 plus 2, that's going to be 3. Then we're going to take this row and multiply by this column here. 1 by minus 2 is minus 2. Minus 2 plus 2, you're going to get 0, right? I don't know if anybody who worked it out from before, if you all got this answer. Those of you from my class. And then you're going to add that now to minus 1, 1, 0, 4. So minus 1 plus minus 1, you get minus 2. Minus 6 plus 1, you get minus 5. And then 3 plus 0, you get 3. And then 0 plus 4, you get 4. Right? I don't know if anybody got this, those of you from my class. Right, so I've seen some people say they got that. Great, right? So that's part A. Now, we have a transformation matrix here. Transformation matrix A and a transformation matrix B. Describe fully the transformation represented by A and of B, right? Now, remember, some students learn up the transformations, some don't, right? And what you can do, right? What you can do, in this instance here, right? We have this matrix here, which is given by 0, minus 1, minus 1, 0, right? If I were to multiply that by our identity matrix, right, you're going to get, in this case here, this is going to be the same matrix, 0, minus 1, minus 1, 0, right? So what happens is that if I were to look at this from a graphical perspective, right, the point 1, 0, that's this point, right, is going to be transformed to 0, minus 1. So 0, minus 1 is down here, right? This point here is 0, 1, that's up here, and then it's being transformed to minus 1, 0. Minus 1, 0 is here. So what's happening here, it seems to be a reflection in the line y is equal to x, minus x, sorry. This here is the line y is equal to minus x, right? So this first matrix here, this one, right, this is a reflection, right, in the line y is equal to minus x, right? I don't know if I'm making any sense to you guys at this stage, right? Right, the last two questions are worth a lot of marks, guys, right? The last two questions worth a lot of marks, right? I think it's like 12 marks or something. Right, so that is what this transformation here represents. To figure out what transformation B represents, right, what transformation B represents, right, so again, you're going to take that matrix. Let's take the 1, 0, 0, minus 1, right? Let's multiply by the identity matrix, 1, 0, 0, 1, and let's see what happens. What's supposed to happen here is that you end up moving to 1, 0, 0, minus 1, right? From a graphical perspective, right, if we look at our coordinate 1, 0, let's see what happens here. If we start off at 1, 0, right, it stays at 1, 0. So it stays right here. Nothing happens, right? If we take 0, 1, so 0, 1 is somewhere up here, but then it becomes 0, minus 1. So it's down here. So what's actually happening here, it seems to be a reflection, right? It's a reflection in the line y is equal to 0 or the x-axis, right? So this here is a reflection, right, in the x-axis, right? All right. All right, guys. So this is all the time that I have for you guys, right? This is all the time that I have for you guys. I have to wrap up now, right? I have to wrap up now. I just want to wish everybody good luck in the exam tomorrow, right? Best of luck in the exam tomorrow. Read your questions carefully, right? Read your questions carefully, right? Try your best to take your time, right? But you have to manage your time as well. Your biggest enemy in that paper, right? The biggest enemy in that paper is time, right? You may run out of time. That's a problem, right? What I would suggest to you guys is that you don't have to do all the questions in order. You can decide which questions you want to do first, right? But choose the questions that you are capable of getting the most marks from first, right? Don't rush and decide you're going to do the hard questions first. Don't do that, right? So please read the questions carefully. Do the ones that you can do first, right, to maximize your marks, right? So I just want to wish everybody good luck in the exam tomorrow, right? Hopefully we get a good paper, right? Hopefully we get a good paper, right? Somebody's asking which year this is. These questions are my own questions, right? These are my own questions, guys, right? All right, guys, so this is it for me, right? Enjoy the rest of your afternoon, everybody. Be safe, right? And I'll see you guys sometime, right? Take care, everybody.